Solve problem 12.2, orbital period of Sedna. The average distance of Sedna from Sun is 77.7 times 10 to the power 9 kilometer. How long does it take Sedna to complete one orbit around the Sun? So here in this question, they have given us the average distance of Sedna from the Sun, which we write as A for Sedna, 77.7 times 10 to the power 9 kilometer. And we need to find how long it takes for Sedna to complete one orbit around the Sun, which is nothing but its orbital period t. So here we are going to use Kepler's third law to solve this problem. We know from Kepler's third law that the ratio of orbital period squared over the cube of average distance from Sun is a constant. And if this ratio is a constant, that means if I take any two celestial object in our solar system, to the cube of their average distance from the Sun must be equal. That means we can write this as T1 squared over A1 cube equals T2 squared over A2 cube, where T1, T2 are the orbital period and A1, A2 are the average distances from the Sun. Now here we can consider one of these ratios belonging to Sedna, but in order to find the time period, we still need this ratio from another planet. So we can take T1 and A1 to be the values corresponding to Earth. And I know that orbital period of Earth, which is the time the Earth takes to go around the Sun, is equal to 1 year. And its average distance from Sun is 149.6 times 10 to the power 6 kilometer. Now these values are not given in the question here, but you can find them in the table that describes the orbital period, the average distances from the Sun, and the radius of the planet. And we took these values from that table. So let's substitute. So first we will rearrange to write everything in terms of T2. So we write T2 squared equals T1 squared over A1 cube times A2 cube. That will give me A2 over A1 cube times T1 squared. Now the choice of taking any planet as 1 or 2 is entirely yours. We could also take Sedna as 1 and the Earth as 2. That will not change your answer as long as you keep the ratio same. So we can find T2 by taking square root. T2 will be equal to square root A2 over A1 cube times T1 squared. Now let's substitute. We get square root. A2 is 77.7 times 10 to the power 9 kilometer. A1 is 149.6 times 10 to the power 6 kilometer. And since we are taking ratio over here, I don't need to convert kilometer to meter because they will cancel anyway. So you can either choose to convert this kilometer to meter or not. It's fine whenever you are taking ratio of the quantities with same unit. So this whole thing raised to the power 3 into T1, which is 1 year. And when you solve this, you get the orbital period of Sedna to be equal to 1.18 times 10 to the power 4 year. Since we kept the value of time T1 over here in terms of year, I did not convert this to seconds. My final answer will also be in here.